How's it going, everybody? It's Thomas. I'm back for a little video here. So over the years, I've had quite a few number of people ask me to try and do a video here on Solidworks on designing an RC airplane basically from scratch. Here on the screen, we've got the T-38 Talon that I've been working on for the past few years. You can see kind of got a transparent model, then quite a bit of the internal structure, the landing gear, fuel tanks, bypasses, inlet ducts, a good bit of everything. Even some servos are in there. So it's taken me, I'm going to say probably about 7 to 10 years to get fairly competent with SolidWorks to where something like this can be drawn up in just a few weeks to months, depending on the complexity of the model, if it's going to be built up or not. So since I've had quite a few people ask me about this, I've changed the name of the YouTube account here. It's no longer my handle that I've used on RC groups and places like that, and RC Universe for years. It's now something a little bit different. If you like it, let me know your comments on that. So basically what I'm going to start doing with the channel is, instead of focusing on things strictly that pretty much everybody does, I mean, everybody can show you how to take an ARF and make it look like the box. What I want to do is I want to take this channel and do things that are a little bit more of what some people refer to as the black arts. Like Dave Platt has done very well. He's shown in VHS tapes how to design things kind of a little bit of an old school way, and I want to do it kind of a new school way with CAD and 3D printing, laser cutting. I mean, the sky's the limit when it comes to technology and the hobby. Really, the only limit is how deep your pockets get. So what I'm going to do is I'm going to start a video series that's basically going to show us how to design an airplane from just some 3 views that you find on the internet, and basically at some point it will look about like this, maybe a little bit more complicated once things start getting more in depth. The complication of your airplane depends on the building style and how in depth with the details you want to get. This one, since it was a 3D printed plug, there's not a whole lot of internal structure to it, since it's an all composite airplane. So it's very, very limited on what you're going to get. But once you start getting into fully built up models, things definitely get a lot more involved. So basically, SolidWorks. Everybody knows SolidWorks that's done any research on 3D CAD programs, and if you've ever researched SolidWorks, you know that it is extremely expensive. And by expensive, I mean a couple of $1,000s for a basic package. SolidWorks has now come to do what they are saying is, well, what they refer to as the 3D experience for makers. $100 a year. It's a pretty good deal. If you got SolidWorks, you can ignore the next couple of bits, but if you don't, here you go. I'm not going to go into too much about what exactly is included with it because I don't have it. What I have is an Experimental Aircraft Association membership, which is about $40 a year, and you get a magazine with it. I think the magazine is worth the $40, to be honest. But with this EAA membership, you get a 50% off discount from the SolidWorks for Makers. So instead of it being $99 a year for SolidWorks, it's $49.50. So by the time you do your $40 a year for the EAA and then your $49.50 with your discount for the SolidWorks, you work out to $89.50. So you save about $10. It's not a big savings, but hey, $10 is $10. One way or the other, it seems like everything in this hobby costs at least $100. But like I said, the EAA, you get a really cool, really good magazine every month. In my eyes, it's better than most of the hobby magazines, and they do a whole bunch of stuff. I mean, check out their website. It's eaa.org, and if you like it, join it. If you don't. Same thing goes with SolidWorks. If you got it already, you don't really have to worry about buying it. But if you do, or if you don't, I should say, have at it and give it a try. $100 for a year. You might like it, you might not. I mean, there's other places like Google SketchUp and Fusion 360. I mean, there's tons of CAD programs you can work with, but this is specifically SolidWorks is one I've been working with exclusively for the past 10 years or so, and I'm self-taught, so I'm not the greatest at it, but I know my way around it well enough to where I feel that now I could help people struggle through the beginning drinks of learning through the fire hose, because it is a very steep learning curve. But again, solidworks.com, or it's the discover.solidworks.com/bakers. I'll put the links to both it and the Experimental Aircraft Association in the description. That way you guys can find it pretty easily. So now that we got rid of all the boring mumbo jumbo, airplanes to design and fly. I don't know. What should we do? There are so many different airplanes. I'm not going to do a Cub. I'm not doing the P-51. I'm not going to do the Spitfire or Focke-Wulf 190. I'm not doing anything normal. So we're going to do something different. Things that I like that are different. Beechcraft Starship. But I've already got a quarter scale one of those. I don't need another big one. Twin engine airplanes I really like, but not everybody wants to do a twin engine airplane because of the cost, and they get kind of complicated. I'm going to try and make this airplane we're going to do as simple but unique as possible. So let's get on old interwebs. So I've got one airplane in mind. The Northrop XP-56 Black Bullet. And we'll sit here and just get on the old Wikipedia. The Black Bullet is kind of an oddball. It's a flying wing. It's a Northrop design, as the name implies. And it used contra-rotating propellers in a pusher configuration with originally a very small vertical tail and then a very large ventral tail that was eventually enlarged to where the vertical and the ventral matched size, basically. They only built two. One of them crashed. Maybe both of them. I think just one of them crashed. The other one, I believe, is at the National Air and Space Museum in storage, I believe. So it's kind of a cool airplane. There's another picture of it. See, it's definitely got some weirdness. It looks like a little bit of probably a flat top on the wing with some bottom wing surface dihedral and then some anhedral out here towards the wingtips. Used a R2800, which I believe is the same engine that was in a B-29 or a Bearcat. I can't remember. Anyways, it's a big, like 4-foot diameter engine, maybe 5. So airplane size-wise, full scale is 42 feet and 6 inches, not super big, and is only about 28 feet long. So that's pretty much the airplane I have decided that I'm going to do this with, because it's fairly simple for the first time, but yet it has some interesting nuances about it that will make it a little more difficult. So, first step, any airplane you want to build, you need a good set of 3 views. Unfortunately, I like weird things, and good set of 3 views and documentation don't come easily. I mean, typically what you're going to find is kind of these little artistic renderings here, and then you might find some good pictures. If you get really, really lucky, you might even find a plastic model kit of it. But, typically you don't get that lucky. So about the best thing you can do is just go around and find something that looks like it matches photos as best as you possibly can get it, and then go from there. And oddly enough, the set of 3 views I pulled off the internet, which weren't these, weren't that good, but those actually look fairly decent. And of course, it's a cardstock model, I believe. So again, this is one of those things where if you want to do a really, really scale model, make sure you do a good bit of research. Find as good of 3 views and cross sections if you can get them. If you can't, you can always make up your own. But again, things start getting very in depth and involved once you start doing that. So there we go. So, all right. let's get out of there and let's pull up what I got. So one thing I like to do is I like to go through here and I just Google as many photos as you can of the airplane. These will come in handy for figuring out cross sections. I'm not worried about doing an extremely scale version of this. I'm just kind of looking for a reasonable semi-scale facsimile of it, because who knows if that thing will even fly once. I do have a Hymax contra-rotating electric power system that I plan to use, so I will have electric contra-rotating props in the back, and the engine or the motors that I have are set up about the same size as a 50 Glow motor. It's about the plan at this point is about the size of a 46 to 50 size airplane, which is about 55 to 60 inch wingspan. And based off the specifications of the airplane, which I have here, we'll do some quick math on the calculator. Just take the wingspan times 12 plus the extra 6 inches. And then we want to do, we'll say, a 60 inch wingspan. So 8.5. So that gives us, what did I just say? I already lost my mind. There we go, 8.5. That gives us a 60 inch wingspan. And then you do the 27. "60-inch wingspan and about 39 inches long." And if you're interested in the height, we'll just do a quick that can't be right. You gotta do it by there we go. Do it by the inches, about 15 inches, 16 inches tall. So not a very large airplane. Really, I think I've seen some wings that are about that size that are bigger in chord than this thing would be long. So that's the plan. We're gonna do 1/8.5 scale. Oddball number, but hey, that's what we get. So there's a couple more pictures of it up on jack stands. Another good side view. Here's the larger vertical tail of the second prototype, I believe. And here's the original prototype of this little, I don't know, that's not even a tail. That's more of a fish fin, I think. But that's a really good picture of the propeller setup. You can see here the cow flaps. Originally, this was designed for a V12 water-cooled. And then the engine just kind of went defunct with its development, so they ended up changing the entire airplane for the R2800, which was extremely underpowered, and the airplane didn't meet any of its design specifications. So again, just like I said, get as many photos as you can. So you see you got the round engine, but you can kind of see here that it's not necessarily a round fuselage. It's more of an egg shape. So you would think this thing is just completely round, but photos prove it wrong. It looks like the only round spot's about right here at the very front of it. So photos, just lots and lots of photos, as many as you can get. Here's a good little frontal view I found of it. Not sure where that drawing, it came off the internet, but it doesn't have any names as far as who made it or anything. Here's another good side view of it, and then a top. This thing had some weird the rudder setup wasn't necessarily on the verticals like you think. It had something where it used air pressure coming in at the wingtips to do rudder control. It's like blown rudders or something. I don't know. I haven't looked into the patent, I'm sure, but there's a good little view of the exit. So I think what I'm going to do with this one is these will be elevons. These were flaps, and then these will kind of be basically just kind of drag rudders. Will be clamshell hinged at the top and the bottom, then they'll just fold out a little bit. And then really might not even need those. I might just put a functional rudder non-scale on the top and the bottom, and then just have that whole area here will both be just conventional elevons. And a good little cutaway drawing I found on the old Googles. So, all right, there we go. So, like I said, I found this photo, that one, and that one. These are reasonably accurate as best as I can tell, and they're good enough for me. Like I said, this is only gonna be a semi-scale airplane, not going for a national champion or anything. So we have these here, these drawings, and the next thing we got to do is we got to open up SolidWorks. Once you get SolidWorks in, you want to see here, hit the little folded corner page, and you want a new part, and that's what we're gonna go with. And once it loads up, here we have the front plane, top plane, right plane. This is basically all the planes are mostly what you're going to be doing your main drawing with, depending on how you want to look or how you want it to look. So I need my dimensions back again. Open up our specifications. I'm going to do some quick math here because I didn't do it earlier. I should have wrote this stuff down. That'd be 330 inches for the length. It's 510 inches for the span, and these are full size dimensions, not the model size. So don't freak out thinking I'm building a big one. And 132 inches for the height. And then I just make little notes down here on the same thing as I do it. So and this height is the airplane as it sat on the ground, not the height of it without the landing gear. So you have to kind of remember that for later. I'll try and remember to explain why. Length here was that 38.82. $60 inches of wingspan, which should be plenty for a decent sized electric airplane. Oop, wrong one, and there we go. Not that one. That one. Oh, nope, that's not what I wanted either. Divided by 8.5 is what I want. 15.52. All right, so hopefully the sound works out. I went and bought a gaming headset with a decent microphone, so hopefully this works for you guys sound-wise. All right, so we got this information here. So the one thing that I have learned over 10 years of doing SolidWorks is when it comes to building, or I should say designing the airplane and into the 3D environment or SolidWorks environment, the best thing you can do is draw it at the scale, at the full size scale. So in this instance, we want to draw the airplane in SolidWorks at 330 inches long and 510 inch wingspan, with it being 132 inches tall. And the reason why I say this is because if you draw it smaller, it's a little bit more difficult to get the surface evaluation that I'll show you later on to look really nice. So SolidWorks has these really awesome things, like they call it zebra stripes and curvature, where it literally shows you the curvature of the surface with either colors or stripes, and it really helps you figure out exactly where on your 3D model that there's a problem. So say for instance you have the shape of an egg. Well, a shape of an egg never has a crease in it that I've seen, at least not one that's not broken. The curvature and color and the zebra stripes tools will really help you find where there's a crease. And typically what I have found is it always happens between the right side and the left side, because you only really draw one half of the airplane, then you just mirror everything else. So where those two sides, in this case it would be the fuselage, come together, if you don't have the curve just right, you end up with a crease down the middle, and those two tools really help you figure out exactly where that problem is. All right, so that's jumping way ahead, but here we go. So first thing you want to do, I'm going to go to the top plane, and we're here and just do sketch. Click sketch, and then up here you have the little sketch. And what it does is you see it brings up the top plane, and it centers it for you in the screen. Next thing you want to do is a corner rectangle. Do your corner rectangle, bring it out here, click once, bring it out here, and click again. And then hit your escape key to close out that tool. Then come to your smart dimension, click that, and then here we want to do the length of the box. In this case, the box is going to be the length of the airplane, or 330 inches. So highlight there and do 330. And you see it doesn't change the size of the box to where it's huge over your screen. It just changes the dimension to match the size of the dimension to match what you want the box to be. And then the next one we're going to do is a wingspan here of 510 inches. We're just going to repeat that same process. And this time, the box will get way bigger. And then you just come up here to a little zoom to fit, the magnifying glass with the 4 arrows in it. Click that, and there you go. And you see we still have the little smart dimension tool. Just hit your escape button, and it goes away. Next thing you want to do is all of this is just going to be as a reference. So come up here to your line, click the little arrow beside it, and come down to center line. Try that again. There we go. And then along your line, bring your mouse over in the little pencil. You can see if you bring and you highlight the line, you get the little yellow box with the symbol inside of it. The symbol means that your point is going to be on your line. Since we want this box to represent the full length and the full wingspan of the airplane, you want to put the center line down the center of the box. So as you see, if I bring it here, I highlight the line, I've got the symbol saying our line that we're going to draw is going to be on top of or part of the line that is now highlighted. If we slide this up to where the little yellow box with the 2 lines are right here, that means the symbol changes. Now, instead of the line being on the end point of the line we're going to draw on the line is now going to be part of the center point of the highlighted line. So do that, and we'll click. And then we can bring it across, and you see now we have a dash dot repeating line. This is a center line. These will become very important when you start doing things like mirrors and drawing new planes and things we'll get into later on. So now, since this line isn't, we don't want the center line coming way down here at an angle. We want it just straight across. So you bring it out, and automatically you just get a continuous line of dashes all the way across your screen, and then you get the little yellow box with a horizontal line. That means your line will be horizontal. So we're just going to move it all the way to the next line, and boom, we're going to click it once it highlights the other line. And now you see it's wanting to draw another line. So at this point, just right click, it's gonna, and then do delete. Well, you just right click and it's making it difficult for me. Just hit the escape key, and then you see I accidentally drew another one. So just come highlight that one, and then come and hit the delete key on your keyboard, and it goes away. So now we have a box, the length and the span of our airplane. So the next thing we want to do is we want to take this center point here and just click on it, and now we can grab it around. If you've noticed, we've got this vertical arrow and then this horizontal arrow, and then if you hover over the intersection of the two, you get a point. That's what they call your origin point. So what I like to do is I like to take this box, bring it over, and match it to where it meets my origin. As you see, I drag, and I get the yellow box with the line and the circle, and then another line coming off of it. That means it's going to intersect. Another way you can do this is come and click your point that you want, and then hold the control button and come back to your origin until that orange dot pops up, and then click there. And then here over, see here on the left side of the box, you have your properties pop up. What you can do is you have your selected entities, your 0.1, which is at your origin, which is now this blue one, and then 0.5, which is here on the box that we drew. And then existing relations. Relations are things like what they say down here, horizontal, vertical, or coincident. In this case, we want the two to be coincident. So hit the coincident button, and boom, you see it moves it right over to it. Then we'll hit the zoom to fit again, and now we can go over here, hit the green check button, and now we have a box that is 330 inches long, 510 inches wide, or in this case tall, on the screen. And this is all we're going to do. We're going to hit exit sketch, and now we see our sketch is here, but it's a gray color. So what I like to do is hit double click on the sketch one and change it. This will be the top view. sketch. And we're done. And then come here and save as until wherever you want to put it. In this case, we're going to put it in XP. And I like to do XP 56 SolidWorks model 1:1. This is a full size model. And pretty much every time I do something, I make sure I change it. So that's the top view. Now we want to look at the right view. So we're going to do the same thing. We're going to click on the right plane, and then we're going to hit sketch. Another way we can do it, hit the right plane, and you see it brings up this little box here. Just hit sketch. And now, we're like, okay, well, we're still looking at the top. How do we get to the other one? Well, you can use your arrow keys, and you can rotate your sketch, as you see this way. And now we get the right plane. Or, now that we're back at the top, you can come up to here, and where it says View Orientation, click on that, and it brings down all this other stuff. You can have the current view, which is a top, or we can have a left, or the front, or the right side, the back, or the bottom. In this case, we want the right side. So we'll do the right side, and there we go. And then we'll do the right side. But as you see here, now our right side is kind of weird because our span and our length is the wrong way around. So sometimes these things just kind of happen. In which case, what we'll do is the front plane will actually become the right plane, or you can rearrange your top view sketch. And what we can do is just, let me go back through that just a little bit slower because I don't want to lose you guys. There we go. There we go. So we're back to the top view sketch. And we notice that the sketch is 90 degrees off. So what I'm going to do is I'm going to use the arrow key there. And you see down here we also have our little things that tell you what you're looking at, depending on how you're going. So in this case, here's the top view, says top. If we do like that, now it says we're looking at the front, but the front is not quite how it's supposed to be, is it? The front is the narrow side instead of the long side. So now that we have that, we'll come right click on top view sketch, edit sketch. And then our center line here, we're going to get rid of that. The 510 for the span, that's going to turn into the 330 for the length. And then this 330 that we originally had for the width is now going to turn into the span. Now again, we're going to come up to our line, hit the arrow beside it, go to center line, come back to the center, and draw our line down to the center and hit the escape key. Now, same thing, we're going to grab that midpoint, hold the control button, hit the origin point, come back to our properties menu here on the left, hit coincide it, zoom to fit, and we're done. And now our front plane is now on the actual front of the airplane. And now our right plane is going right down the center. So there's that. And again, make sure you save it. Up here, do the right view. As you come over here, you'll see the front plane will be over here. So what I actually like to do is I'm kind of backwards. I like to do it to where the right side, the front plane is actually to my right. So same thing. Here on the right plane, we're going to click on it, hit sketch, come back up to our corner rectangle, draw another one, and there. In this case, I'm going to show you a little bit different way of doing the origin point on the center line. So here, click on your origin, hold down the key, the control key, click the line, and then come over here to your properties and hit midpoint. And boom. Your box is right there at the midpoint. This line is on the midpoint of your origin. Or to rephrase that, the origin is on the midpoint of this line. Now the next thing we can do is the drawing we did, the top view sketch. Take the point, take your point here, it's highlighted by blue, hold the control key, highlight your line, Again, midpoint. Done. And then the height. The height of it was 132 inches. Now a smart dimension, once again, to the line, click on it, type in 132 inches, and we're done. And then we can exit that sketch. And this sketch, I'm going to name side view sketch. And then we're going to save it. And then the front plane. Highlight the front plane, sketch. And then we come up to here, and we're going to go to the front. Take our corner rectangle once again, draw it again. Now I'm going to use the down arrow button twice, just to get where I want. I'm going to take, I did the down arrow twice, and then I did either a left one, or a right one once, just to get kind of an oblique view. The corner of the rectangle, click it, hold the control button, highlight the line with your mouse, click it, midpoint. Do the same thing here. Click this intersection point, hold the control button, highlight your line, click it, midpoint. And we're going to do that for all 4 of these little corners. Highlight the vertex here, hold the control, click your highlighted line, midpoint. Same thing here. And now you'll see this one automatically says it's black. Before we did this one, see both of these lines are blue. This means they are not fully defined, I believe is the term they use, fully defined. So if it's not fully defined, it means that you can just grab it and you can move it all over you want. So we're just going to go crazy with it. But as soon as you click that vertex, hold the control, hit that highlighted line with your mouse button and do midpoint, boom. This line is now black and this line is black. So you can't move them. Nothing happens. Because the software knows that this point is in the middle of this line, this point is in the middle of this line, and this point is in the middle of this line. So this line has a fixed width or length that it can be, and it can't go any farther, because if it goes any farther, this point will no longer be in the middle. So now that we have that done, you can exit the sketch, do front view, sketch, we're done, and save it. And now what we do is we have a mostly 3-dimensional box that shows the dimensions of the airplane that we're going to draw. So it's a lot of information. I'm going to kind of stop it here for now and go grab some dinner. And once I get done with all that, I'll come back and we'll get started again. And I'll go with video number 2. So until next time, y'all have a good one. We'll see you back here shortly.